Hi guys, it's Charlotte here from Studentium and I am here to make your maths revision as stress-free and simple as possible. So here what I have is a perfect example of a differentiation modelling question, which is often referred to as optimisation. Okay, so these optimisation questions I find my students always come up with a lot of resistance against. They don't know where to get started, they find them really challenging. But I'm here to use this as an example to give you a real basic framework as to how to approach these questions, okay? So let's have a look here at question A and see how we get on. So if we look at this, we're told that figure 3, so this is the figure, shows a design consisting of two rectangles measuring x centimetres by y centimetres, so that there's our x by y, joined to a circular sector of radius x, so there's our radius, and an angle of 0.5 radians. We're told that given that the area of the design is 50 centimetres squared, let's show the perimeter of the design is given by this. So P equals 2x plus 100 over x. Now, the first place that I'm going to mention here is my students, and any student out there, I always find that where they get wrong is they feel like you need to use this show that, this actual answer to get somewhere with it. And they're distracted by it. They look at it and they think, how am I going to find 100 over x? I'm stuck. But what my top tip is with questions like this, part A, is I want you to look at the data they have given you. Okay, so for part A, that's what I'm going to say. Look at data given and ignore the show that. Ignore it, okay? I want you to simply look at the data that came before the question and to ask yourself, what maths can I do? Okay? What maths can I do? And I know that might seem odd, but I promise you this is going to work, all right? So I'm going to have a little look here now at what data they've given me, and I'm going to highlight the important bits. So we're told that the area of the design is 50 centimetres squared. And of course, there's all the labelling that you can see on the diagram. So what can we do with this? Well, the first thing in my head is, can we work out the area? Because we know what the area equals. So how about then we look at the diagram they've given us and use our maths knowledge to calculate what the area is and then put that equal to 50. Okay, so let's work out the area. So the area, it consists here of two rectangles and a sector. Now we know that the area of a rectangle is base times height, isn't it? So looking at the particular rectangles we have got here, we can see that that is going to be x times by y, all right? So each rectangle, base times height, is just going to be x times by y, all right? So the first one, let's say, was this rectangle here, and then the other rectangle, let's make that one green. That is what that second one was, okay? So then we have got a sector. Now, with sectors, this is almost like a little subtopic that we need to know about. We need to know that the area of a sector is equal to a half r squared theta, where theta must be in radians. Okay, that is essential to use that formula. So in this case here, the radius we were told in the question was equal to x, and the angle is 0.5 radians. So therefore we could say that the area of that sector is a half x squared times theta, which is a half. Okay, so that there would be what the area of the sector is. Now this here that we've just got, this little equation for the area, is something now that we can use moving forward through this question, all right? So we know that the area is the sum of all those things, which we can tidy up, but we also know that the area is equal to 50, okay? Because in the question, they tell us that the area of that design is 50 centimetres squared. So what we've got here is a little equality, all right? And what I would recommend we do now is we tidy this up, okay? So xy plus xy gives us 2xy. And then a half x squared times another half will give us 1/4 x squared. Or you could call that x squared over 4. And that is equal to the 50 that we've got there. So that there is where we reach kind of a dead end. There's not really anything obvious that we can do there. And this is when I would have a think of what the show that is. And again, I'm not going to really pay too much attention to the actual outcome, but I know that we need to find perimeter, all right? And because the question is asking us to find the perimeter, I would recommend that we now look to the shape again and work out what the perimeter is, okay? So the perimeter of a shape like this is going to be equal to the sum of all the sides, okay? So the perimeter will be equal to x plus y plus another y plus another x plus another y, and then we get to this curved region, okay? So that there is an arc length. And again, we've got a little formula for arc length that we have learned about, and that is r theta, where theta again must be in radians. So in this particular case here, the radius of this sector is x, and theta we know equals a half. So we could say that r theta, the arc length, is equal to a half times x, or 0.5 times x. And then finally, we've got one last little bit left, and that there is our y. Okay, so plus y again. So for the perimeter then, we can tidy this up. We can see that we have a load of different x's, 1, 2.5 of x. So that gives us there 2.5x, so we could call that 5 over 2x. And then for the y's, we have 4 y's in total there, so plus 4y. So what we need to do now is we are going to need to have a think, where are we going to go with that? And this is where I do look at the show that, and I play a little game of spot the difference, because what we've got written down here should be equivalent to what they have written down. But there's going to be an obvious difference. And when I say a difference, I mean, is there anything that we have, any letters, any variables that they do not have in this question? And so looking at this, I can see that there's no y in theirs, but there is a y in ours. So this is where we can solve this. Because if we go back to our equation that we worked out for the area, that has two variables, it's got an x and a y. We can rearrange that to get 2y as the subject, and then substitute that y into what we have here. And then we should get the same as what they have. So rearranging this to find y, I will do 2xy equals 50 minus 1/4 x squared, and therefore y would be equal to, if we divide through by 2x, we can just get y equals 50 over 2x, and then 1/4 x squared over 2x, which if we simplify that, we end up getting y equals 25 over x minus 1/8, because 1/4 divided by 2 is an 1/8, and then x squared over x is just x. So this is now something that we can substitute in place of y, and we should get a good answer, all right? So let's put it in. So we know that p equals 5 over 2x plus 4 times, and then in place of y that we have in this formula, so let me highlight it for you. In place of this y, I'm going to replace it with 25 over x minus 1/8 x. And then we will simplify this. And I promise you it's going to work, because these just always do. So then that leaves us with p equals 5 over 2x plus 100 over x minus 4 times 1/8 leaves us with a half x. And this then gives us 5 over 2x minus a half x just leaves us with 2x plus 100 over x. And that is what we wanted. So see, we managed to finish that off now absolutely perfectly. And we have there our 5 marks, all right? So my main tips, let's just mention them again. Look at the data given. Ignore the actual show that until later down the line. And just ask yourself, what maths can I do? Okay? So that there is the first part of this question. And now let's look at parts B, C, and D. And for this, I really want you to realise that actually, it does not matter if you could do A. You can still, and you should still do parts B, C, and D. All right, so let's dive into that then. Okay, so now to look at part B. All right, so for part B, we're told to find the value of x for which p is a minimum. So whereas part A, it really didn't come up much anything to do with this differentiation, now we're being asked to find a minimum. And if we're ever asked to find the minimum of a curve, then that is math speak for find the differential. So in this case, that would be dp dx, but of course that might be dy dx or something else. So find that differential and put it equal to 0, because remember, at a minimum point, the gradient is 0. So here then we need to differentiate this equation for p equals 2x plus 100 over x. And to do that, we will want to rewrite that using negative powers for the 100 over x. So that becomes 100x to the minus 1. And so let's differentiate then. So dp dx will equal to 2, because when you differentiate 2x, you just get 2. And then 100x to the minus 1, you're going to multiply through by the minus 1 and get minus 100. And then you're going to take 1 away from the power, so you'll get x to the minus 2. And we want to equate that to 0 and solve it. So for me personally, whenever I want to rearrange things, I don't like negative powers anymore. So we put it as a negative power temporarily so we could differentiate. But now I'm going to rewrite it as a fraction. So we've got 2 minus 100 over x squared. And I know that I want that to be equal to 0. So now what I would do is I would rearrange this and I would get x as the subject. So here I would say 2 equals 100 over x squared. So there I can say x squared equals 50. And then finally, x would equal the root of 50, which you could simplify down a bit. You could say that x is equal to 5 root 2 if you wanted to. So that there is the value of x for which p is a minimum. And you might choose to put that into the calculator to get an actual value for that, a numerical value. So for C, we want to show that p is a minimum for this value of x. So we've found out where the minimum is, but now we want to show actually that p is a minimum for this value. And so to do that, what we need to do is to remember, if we ever want to show that something is a minimum or a maximum or whatever, we need to do the double derivative. And when we're looking at it being a minimum, that is when we substitute in x into our double differential equation. And if we get a positive value, then it is a minimum. All right. So in this case, we already know that dp dx is equal to 2 minus 100 x to the minus 2. But let's now work out what the double differential is. So that will leave us here with 200 x to the minus 3. So here then, what we have is a value which we can rewrite if we wanted to as 200 over x cubed. But we know that we are looking at what is it equal to when x equals 5 root 2. And if you were to substitute that into this, we know even before we substitute it in that we're going to get a positive value for this. Therefore, it's a minimum. So for that particular question, we needed to use the fact that the double differential is positive when we have a minimum. And for part B, we use the fact that if we have a minimum or a maximum or any old turning point, the differential is equal to 0. Okay, so for part D then, find the minimum value of P in the form k root 2. So in this case here, they actually want us to get the minimum value of P. So that means we need to find out what P is. And to do that, we want to go back to that original equation, which is that P equals 2x plus 100 over x. And we want to substitute in our value for x. So that's 2 times 5 root 2 plus 100 over 5 root 2. So simplifying this, I get 10 root 2 plus, and then 100 over 5 gives me 20. So I've got 20 over root 2. And I know that that is irrational. Obviously, that isn't in the form of k root 2. So 20 over root 2, I'm going to rewrite by timesing the top and the bottom of it by root 2, so root 2 over root 2. And that then leaves me with, so I've still got the 10 root 2. I'm going to have add 20 root 2 over 2, which is just there, just 10 root 2. So I've got 10 root 2 plus 10 root 2, which leaves me with 20 root 2. So when they want us to then find the exact minimum value of the function, you take what you found out for the value of x at that minimum, and then feed that back into your original equation. But you know what? Every single one of these questions is basically the same framework. So if you have any doubts at all that this is stuck, honestly, go to find another question now and see how you get on. And I bet if you follow this framework, you'll actually think, how did I ever find this hard? All right, so really, really great work today. Make sure you subscribe and let me know if there are any things that you would like me to cover. That's great. Well, I'll speak to you soon then. Bye.